The neutral conductor in a subpanel should not be bonded to the panel itself. The fundamental principle is that the neutral conductor should only be bonded to the equipment grounding conductor at the service entrance. This single point of bonding is crucial for maintaining a safe and effective electrical system. Bonding the neutral conductor at multiple points, such as in a subpanel, can inadvertently create a ground loop. A ground loop occurs when there are multiple paths for current to return to the source. This can lead to unwanted current flow through the grounding system, which can cause a variety of problems. Firstly, a ground loop can result in elevated levels of electromagnetic interference, often abbreviated as EMI. This EMI can disrupt the operation of sensitive electronic equipment, causing malfunctions or inaccurate readings. For instance, audio equipment might pick up unwanted hum, or data communication lines could experience errors. Secondly, ground loops can create a shock hazard. If the grounding system is carrying current due to a ground loop, any contact with the grounded surface could result in an electrical shock. While the current might not be high enough to trip a circuit breaker, it can still be a dangerous situation. Thirdly, the presence of ground loops can compromise the effectiveness of ground fault circuit interrupters, frequently called GFCIs. GFCIs are designed to detect even small imbalances in current between the hot and neutral conductors. If a ground loop is present, it can mask a ground fault, preventing the GFCI from tripping and protecting against electrical shock. The National Electrical Code, frequently called the NEC, provides detailed guidelines on proper grounding and bonding techniques. These guidelines are designed to minimize the risk of ground loops and ensure the safe operation of electrical systems. Specifically, the NEC mandates that the neutral conductor be bonded to the equipment grounding conductor at the service entrance. This is the point where the electrical service enters the building. In a typical residential installation, this is usually at the main electrical panel. The purpose of bonding the neutral and grounding conductors at the service entrance is to provide a low impedance path for fault current to return to the source. This low impedance path helps to ensure that overcurrent protection devices, such as circuit breakers and fuses, will trip quickly in the event of a ground fault. If the neutral and grounding conductors were not bonded at the service entrance, the fault current might not be high enough to trip the overcurrent protection device, resulting in a prolonged and dangerous fault condition. In a subpanel, which is an electrical panel that is fed from the main panel, the neutral conductor should be isolated from the panel enclosure. This means that the neutral conductor should only be connected to the neutral busbar within the subpanel, and the neutral busbar should not be bonded to the panel enclosure. The equipment grounding conductor, on the other hand, should be bonded to the panel enclosure. This ensures that the panel enclosure is properly grounded, providing a safe path for fault current to return to the source. To reiterate, the grounding conductor should be connected to the ground bus bar and then to the metal enclosure of the subpanel. The ground bus bar should also be connected to a grounding electrode conductor that runs back to the main service panel. This creates a continuous grounding path throughout the electrical system. Understanding the difference between grounding and bonding is essential for safe electrical work. Grounding refers to connecting an electrical system or equipment to the earth. This provides a reference point for voltage and helps to stabilize the electrical system. Bonding refers to connecting different metal parts of an electrical system together. This creates a low impedance path for fault current to flow, which helps to ensure that overcurrent protection devices will trip quickly in the event of a ground fault. In a subpanel, the equipment grounding conductor is responsible for bonding the metal parts of the subpanel together and providing a path for fault current to return to the source. The neutral conductor is responsible for carrying the unbalanced current from the load back to the source. It is important to keep these two functions separate in a subpanel to avoid creating a ground loop. Proper wiring practices are crucial for maintaining a safe and reliable electrical system. When wiring a subpanel, it is essential to follow the NEC guidelines and ensure that the neutral conductor is isolated from the panel enclosure. This will help to prevent ground loops and ensure that the grounding system is working effectively. Incorrect wiring can have serious consequences, including electrical shock, fire, and equipment damage. Therefore, It is always best to consult with a qualified electrician if you have any questions or concerns about wiring an electrical system. The NEC provides comprehensive information on grounding and bonding requirements. It is updated regularly to reflect the latest safety standards and best practices. It is important to stay up to date with the latest version of the NEC to ensure that your electrical work is compliant and safe. In addition to the NEC, there are other resources available to help you understand grounding and bonding principles. Many electrical training programs offer courses on grounding and bonding, and there are also numerous online resources available. By investing in your electrical education, you can improve your skills and knowledge and ensure that you are performing electrical work safely and effectively. To summarize, the neutral conductor should never be bonded to the subpanel enclosure. The equipment grounding conductor should be connected to the metal enclosure of the subpanel, and the neutral conductor should be isolated from the enclosure and connected only to the neutral busbar. This arrangement helps to prevent ground loops and ensures that the grounding system is working effectively. Always consult the NEC and a qualified electrician for guidance on proper grounding and bonding techniques. Maintaining a safe and reliable electrical system is essential for protecting people and property from electrical hazards. By following proper wiring practices and adhering to the NEC guidelines, you can help to ensure that your electrical system is operating safely and effectively. Understanding the principles of grounding and bonding is a fundamental aspect of electrical work. By mastering these principles, you can become a more skilled and knowledgeable electrician and contribute to the safety of electrical systems. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. If you are not comfortable performing electrical work, it is best to hire a qualified electrician to do the job. They have the training, experience, and tools necessary to perform electrical work safely and effectively. Subpanels serve as distribution points for electrical power. They receive power from the main service panel and then distribute it to various branch circuits throughout a building. Subpanels are commonly used in residential, commercial, and industrial settings. They allow for more efficient distribution of power and can help to simplify the wiring of a building. When installing a subpanel, it is important to choose the correct size panel for the load that it will be serving. The panel should have enough circuit breakers to accommodate all of the branch circuits that will be connected to it. It is also important to ensure that the panel is properly grounded and bonded, as described previously. A properly installed and maintained subpanel can provide years of reliable service. However, it is important to inspect the subpanel regularly for any signs of damage or wear. If you notice any problems, such as loose wires, corroded connections, or damaged circuit breakers, it is important to have them repaired promptly. Neglecting these issues can lead to electrical hazards and equipment failure. Over time, electrical components can degrade due to heat, moisture, and other environmental factors. Regular inspections can help to identify these issues before they become serious problems. Circuit breakers should also be tested periodically to ensure that they are tripping properly. A faulty circuit breaker may not trip in the event of a ground fault or overcurrent condition, which can lead to electrical shock or fire. Testing circuit breakers requires specialized equipment and knowledge, so it is best to hire a qualified electrician to perform this task. In summary, proper grounding and bonding are essential for the safe and effective operation of subpanels. By following the NEC guidelines and consulting with a qualified electrician, you can ensure that your subpanel is wired correctly and that it will provide years of reliable service. Remember to inspect the subpanel regularly for any signs of damage or wear and to have any problems repaired promptly. This will help to protect people and property from electrical hazards. The principles of grounding and bonding apply to all types of electrical systems, from residential wiring to industrial power distribution. Understanding these principles is essential for anyone who works with electricity. Whether you are an electrician, an engineer, or a homeowner, it is important to have a solid understanding of grounding and bonding techniques. This knowledge will help you to perform electrical work safely and effectively and to protect yourself and others from electrical hazards. Remember that electricity is a powerful force, and it should be treated with respect. Always follow proper safety precautions when working with electricity, and never attempt to do electrical work if you are not qualified.